We're back. Okay, so the antiderivative, if I have root x, I need to write it as x to the 1/2. I need to write my things as x to a power for this backward power rule or reverse power rule to work. I can't have powers like shoved under roots or in denominators or things like that. They have to just be sitting x to a power. So x to the 1/2, antiderivative world, x to the 1/2 plus 1 divided by 1/2 plus 1 all plus c. I am not going to let you leave that. Okay? Nope. No, I can't. I can't. No. Okay? Because there's nothing in there you can't do. Right? There is nothing in there you can't do. And if we write it a different way, it actually is simpler. There's really not a lot of difference between x to the 5th over 5 and 1/5 times x to the 5th. But x to the 1/2 plus 1 divided by 1/2 plus 1, yeah, that's a lot more confusing than a simplified version of that. So, heck yeah, you have to add 1/2 plus 1 together. Now, luckily, adding 1 to a fraction, we're usually pretty sufficient at that. If we're really not, we could just... I do want you to leave it in terms of fractions, though. So I'm actually going to come over here, and I'm going to make this x to the 3/2 divided by 3/2 plus c. Okay, because 1/2 plus 1 is 1.5, or 1.5, which is 3/2. Okay. We don't use decimals for this. We don't use decimals. We use fractions. And I don't even let my pre-calcs leave stuff like this. I do not let you leave things divided by fractions. No way. When you divide by a fraction, you multiply by its reciprocal. So x to the 3/2 divided by 3/2 needs to be 2/3 times x to the 3/2 plus c. Some elementary teachers spent a lot of time teaching you keep, change, flip. So I'm going to make sure we still do that, right? Keep, change, flip. X to the 3/2 divided by 3/2. If I write that down again, x to the 3/2 divided by 3/2 is what we have after we take the antiderivative. So that's x to the 3/2 times 2/3. And so we can write 2/3 x to the 3/2 with the floaty, kind of floaty fraction in the front. Or if you don't like the floaty fraction, he goes up top with the 2. I don't care whether it's this guy or this guy. Floaty fraction or clear top and bottom, clear numerator, denominator, I don't care about that. But if you leave them unsimplified for me, you're never going to get a 100. Okay? Everything can be beautiful, and I will not give you a 100 if you can't simplify it. You have to simplify to get full credit. I'm not going to mark them all wrong, but I'm going to be like 95, 99, 99.999. You're not getting 100 if you don't simplify things for me. Divide by 1/2. Multiply by 2/3, 2/3 x to the 3/2. If there's no other coefficient here, that's actually pretty easy to see. You're like, oh, look, that's that fraction. That's its reciprocal. That happens a lot. So that's the one challenge, and that will be if we have a root or we have an x raised to a fractional power. So anything that makes a fraction power, roots can do that. You know, something like, and these are the kind of problems that always show up in like just the simplifying part. It's like you have the cube root of x squared. The algebra 2-ness of that is, hey, let's write that with a fraction. right? A bunch of Algebra 2 teachers sitting somewhere like, yes, I taught them that a million times. And now we're going to do this. Thirds plus 1. Now, I literally do not write this plus 1 thing out every time. I do it in my head. So when you look at my answer keys, you are not going to see this in between step. You're going to see the result of adding by 1. And I'm fine. You should, if you're comfortable enough, I think that's acceptable. You know that 1, we know that 1 is the same numerator denominator, common denominator with 2/3, so 1 is 3/3. So x to the 5/3 divided by 5/3 plus c, 3/5 x to the 5/3 plus c. That would be the answer. I don't need you to take it back to a root. That's like the 3rd root of x to the 5th. This is way more useful. Okay, so the other thing, things that look quotient-y. Exponents and denominators. Not good for backward power rule. I'm going to add number 6 to a new page here. We'll be all organized later. So number 6, when I have 1 over x squared, I need to think about that as x to the negative 2. Okay, if it was 5 over x squared, it would be 5x to the negative 2. So then, this is going to happen. I'll do my reverse backward power rule trick stuff. And I'm actually going to be a little nicer to you on this guy. I do expect you to simplify the arithmetic. X to the negative 1 over negative 1. But I'm actually perfectly okay with you stopping there. There are some other ways to write that, but I'm okay with that. Now, the hard thing about that is, in your mind, it doesn't feel like this got bigger. Because when you look at that, you tend to ignore the negative. So you look at that and go 2, 1, it didn't get bigger. You want to go 2, 3. Problem is, it's negatives. So a negative 2 to a negative 3 is not plus 1, it's minus 1. Negative 2 plus 1 is negative 1. We got to watch when we're doing negatives, we got to watch for that. It's so tempting. It's so tempting. And we do that with our derivatives too. We kind of like, just because our mind processes, you're like, I'm getting bigger or I'm getting smaller. If I'm getting bigger from negative 2, I'm getting closer to 0. If you would prefer to write this a different way, 1 over negative 1x to the first plus c would be a good answer, which you could also throw the negative up in the numerator and still include the 1. I mean, 1s are weird because you don't actually have to have 1s for coefficients. So this is okay, this is okay, this is okay. These are all good answers. I don't necessarily need you to not have a negative exponent. There's not a huge amount of benefit to having it written as a fraction with a positive exponent versus a negative exponent, at least for what we're going to do. So I'll let you go on this one. This doesn't trigger me like the fraction stuff does. So you're going to have to worry about this when you see stuff that would have normally been like, hey, I need quotient rule. So stuff like in number 8, we got to change those to negative exponents. And look at number 7. Look, we have a fraction and we have a fraction exponent that's also going to be negative. Number 9, we've got some fraction coefficients. And so a little bit of fraction multiplication is going to need to happen to clean these up. To finish up today, I want you to go ahead and try 7 and 8 and 9. If you want to do them in order of difficulty, I think based on what we just did for number 6, you might try 8 first, and then 7, and then see what you can do with number 9 with those fractions. Okay, let's try those 3.